Determine the reactions at the surfaces of contact and the tension in the string AB shown in figure. The radii of spheres R1 equal to R2 equal to R3 equal to 200 mm. Three spheres are having 1 kilonewton each self-weight and they have radius each equal to 200 mm. We have to find tension in the string AB. We have to find the tension in this string AB. Here, the center to center distance here, it is given as 600 mm. That is, length of the string is 600 mm. And we have to find reactions at contact surfaces RD, RE, and RF, and RG. First, consider sulfate. These are sulfates, and as because of this 1 kilonewton force, 1 kilonewton self-weight, there will be tension in the cable. They will be pulling towards like this, each other like this, and this is action of 1 kilonewton on sphere A and B, and these are the reactions. This is reaction from A and B on C. So this is action, and this is the action on the string, and these are the action at contact points D and E. These are reactions of spheres A and B on sphere C. So this will be reaction. This will be reaction from A to C, from B to C. And these are reactions from ground, and these are reactions from ground, and these are reactions from the string, and these are reactions from C on A. This is reaction of C on A, and this is reaction from C on B. These are the contact points. These are contact points, contact points, contact point, contact point. Geometry part. This half distance will be equal to 600 by 2, that will be 300 mm, and this 200 equal to 400. Now say it is theta, and this is 300, this is 400. This theta we get by tan cos inverse of 300 by 400. We get 41.41 degrees. Writing theta values, and this is 1 kilonewton. This is reaction at F. This is reaction at G, and this angle is 41.41. This angle is 41.41, and this remaining angle will be 48.6. This remaining angle will be 48.6. This angle we get as 180 minus 48.6, that will be 131.4, and this angle is 48.6. This angle is also 131.4 degrees. Now this total angle will be 97 degrees, 97.2 degrees. This is 131.4, and this is also same. Now applying Lamy's theorem, 1 kilonewton by sine of the angle between other two forces, 1 kilonewton by sine of 97.2, and RF divided by sine of the angle between other two forces. Sine of the angle between other two forces is 131.4. RF by sine of 131.4 degrees equal to RG. RG by sine of the angle between other two forces, sine of 131.4 degrees. So now consider RF here. This sine 131.4 4 and sin 131.4, they are same. Here RF equal to Rg, so RF equal to Rg equal to 0.756 kilonewtons. Now consider this sphere. So the tension in the string, they will be moving like this. So here this angle is 48.6 and this is self weight and this is tension in the string and this is reaction from the ground. Same here, because the geometry is symmetrical, so Rg and Rf will be equal and this Re and Rd will be equal. We can calculate for this one or this one. Now calculating for this one. Applying equilibrium conditions, that is summation fx equal to 0 and summation fy equal to 0. In this case, we cannot apply Lami's theorem because here 4 forces are there, and resolving this force horizontally, this force is T, directing towards positive x-axis, so plus T, and resolving this force horizontally, it will be Rf sin 48.6. So Rf sin 48.6 equating to 0, we get T value, and resolving forces vertically and equating to 0. Resolving this force vertically, it will be Rf sin 48.6. It is directing towards negative y-axis, so minus Rf sin 48.6, and this force directing downwards, so minus 1. So plus, now this force plus Rd, it is directing towards positive y-axis, so Rd plus Rd equal to 0. So Rd equal to 1, this one plus, and plus Rf value we know, so substituting for Rf value we get Rd equal to 1.5 kilonewtons. Now similarly here this force is directing towards negative x-axis, so minus T. This force horizontal resolution of Rg directing towards positive x-axis, so plus Rg sin 48.6 equal to 0. From this we get T value. Substituting for Rg we get T value, and resolving this force vertically, so this force is directed downwards towards negative y-axis, so minus Rg cos 48.6 minus Rg 48.6, and this force minus 1 directed towards negative y-axis, so minus 1, and this force plus Re directed towards positive y-axis, so plus Re equal to 0. Substituting for Rg, Re will come to 0.5 kilonewtons. We got Re value, T value, Rd value, Rf and Rg value.